Alright, here we go. Let's get started here. This is day number 7, chapter 3 on related rates. I'll read this word problem. Oil rig springs a leak and spreads in a circular patch. If the radius of the patch increases at a rate of 30 meters per hour, how fast is the area increasing when the radius is 100? So some important stuff that we need to know here. First of all, we're trying to find dA dt. We're given, or that is the area, change in area with respect to time. We're given that dr dt is 30 meters per hour. We want to know what the change in the area is when the radius is 100. So here we have our important equation. Of course, my marker decides to go to bed. Let's get a new one. So if I want to know what dA dt is, I take the derivative with respect to t of both sides of this equation. Another poor marker. Let's try another one. So the derivative of the left side with respect to t is dA dt. The derivative of the right side with respect to t would be, using implicit differentiation, 2 pi r times dr dt. Now we have some knowns. We know that r is 100 when we want to know dA dt, and dr dt is 30. So I'm going to do a direct substitution. dA dt, or the change in area with respect to time, at the instant that r is 100, is going to equal 100 times 30 is 3,000 times 2 is 6,000 pi. Consider the units here. This would be meters squared per hour. Okay, pretty basic related rates problem. Let's try another one. Okay. Example 2, an observer stands 200 meters, I couldn't even read my own writing, from the launch site of a hot air balloon. The balloon rises vertically at 4 meters per second. How fast is the angle of elevation increasing 30 seconds after launch? So we're looking for d theta dt, right, that angle change. We know dy dt, or the height, is changing at a rate of 4 meters per second. We want to know what the angle change is at t equals 30 seconds. Well, if t equals 30 seconds, if the height is changing at 4 meters per second for 30 seconds, that's 120 meters. So let's write an equation here relating these three items. So the tangent of theta equals y over 200. Therefore, theta equals arctangent of y over 200. Now we're able to take the derivative of both sides. This is going to require some knowledge of the derivative of arctan. So on the left side we get d theta dt. On the right side we get 1 over 1 plus y over 200 squared times the derivative of the inside, which in this case will be dy dt times 1 over 200. Okay, so as we look at this, we're just going to do a direct substitution. That'll be 1 over 1 plus, let's look at y. Y is 120. So 120 over 200 would be the same as 3/5, I believe. So that'd be 3 over 5 quantity squared times 1 over 200 times dy d theta, which is 4. So this piece right here is going to reduce to 1 over 50. This piece right here, let's go ahead and do a little simplifying, will be 1 over, this will be 9/25. This is 25/25, so there'll be 34 25ths times, like I said, 1 over 50. All right. If I reduce this down, this 25 reduces with the 50, making this a 2, which ends up giving us d theta dt is equal to 1 over 68 radians per second. So this angle right here would be increasing at 1/68th of a radian per second. All right, one more example here, and we'll call it good for the lesson. Sand falls from an overhead bin, creating a conical pile with radius 3 times the height. If sand falls at 120 cubic feet per minute, how fast is the height changing when the height equals 10 feet? Okay, a couple critical items here. Equation for the volume of a cone, 1/3 pi r squared times h, as well as r equaling 3 times h. So we're seeking dH dt, we're given dV dt, and we want to know what dH dt is when h equals 10. Okay, so let's take the volume formula, and since we want to know dH dt, we're going to get rid of r. So we're going to take 3h and we're going to plug it in for r. So the volume formula is going to be 1/3 pi times, instead of r squared, we'll go 3h squared times h again. The 1/3 out here and the 3 squared right here will reduce, giving me 3 pi h cubed. Now I can take the derivative with both sides with respect to t. Be dV dt, or the change in volume with respect to time, would equal 9 pi h squared times dH dt. Again, the implicit piece coming in with dH dt. That's something we got to get comfortable with. We know dV dt is 120. We know h is going to equal 10. Now we're trying to isolate dH dt. If I'm doing this right, I think I'm going to reduce this correctly. This would be 120 over 900 pi is equal to dH dt. I'm going to reduce that. So dH dt along with units attached would be 2 over 15 pi feet per minute. Looks like the height is changing at that rate per minute. All right, that's related rates involving some skills with implicit differentiation. That'll be it. See ya.